So we now have two risky assets. We have asset 1 and asset 2. Both are risky because neither of them lie on the y-axis, so they have a positive standard deviation. There is some risk. And we don't know what the relationship is between the two assets. We're just assuming, for now, that the correlation between them, there is no diversification, that the correlation coefficient is equal to 1. And what we're kind of showing but not really proving and skipping a bunch of math is that the allocation line between these two assets is a straight line. And we're kind of showing that because the risk is just the weighted average, and then down here the return is just the weighted average. And so since the risk is a weighted average and sort of linear, and the return is a weighted average and also linear, it's the case that the allocation set is a line. But what happens when rho gets smaller? Remember, we set it to 1, which is the maximum. What happens when rho gets smaller? Well, we know that portfolio risk must get smaller. So let's see what happens. So it turns out portfolio risk, sigma p, as a function of the weights, W1 and W2, for a given level of diversification, rho is a parabola. It's really the square root of a parabola. There's about 3 pages of algebra in the textbook that goes through this. We're just going to use a spreadsheet. And here are some shots from a spreadsheet. And here's the idea, is that I have those same two assets, and the first asset has a risk of 13 and a return of 8, and the other asset has a risk of 20 and a return of 13. And here's the relationship between them when rho equals 1. Here it is when rho equals 0.5. And so you can see that any spot on the straight line now has less risk because I move to the left. And when the correlation is 0.25, I'm even further. When the correlation is 0, I'm even further. So if the correlation is 1, I'm on a straight line between them. But now I can achieve less risk with lower correlation. And you can see as the correlation becomes negative, I can achieve a lot less risk for the same level of return. So for example, for a portfolio with a 10% return, I have 15% standard deviation, but for that same 10% return portfolio, you can see we have about 12% standard deviation. And here at 10%, we're at, let's call it 10.5. And here at 10%, we're actually below 10. We're over at, let's call it 9. And here, 10%, I'm way over at 5. So for the same return of 10% in all of these different combinations of asset 1 and asset 2, all we're doing is we're varying the correlation. And I want to be clear here, we don't get to choose what the correlation is between the two assets. It just is. We're saying, what if it's 1? What if it's 0.5? What if it's negative 0.75? And the takeaway from all of this is that the lower the correlation, the greater the standard deviation, the greater the diversification, the lower the correlation, the further to the left this portfolio allocation line bows, and the less risk is achievable with the same return. Less risk is realized with the same achievable return. Just one quick note. The textbook spends a lot of time on calculating the minimum risk portfolio weight, trying to find this exact spot on the curve. And this is a bit of a holdover from when we needed to sketch the curves. But since the machine now does the sketching for us, we don't really need to find this minimum risk spot. If you know this spot, you know this spot, and you know the minimum risk spot, and you know it sort of looks like a parabola, it's easy to sketch. But again, we're not going to do that. So we'll skip the minimum risk portfolio weight and now try to figure out where we want to be on this line.